Good morning, this is Kasturi Day. Today again I'm come to discuss the a chapter from physics according to ICSE syllabus class A. This is physical quantities and measurement. Okay, so in my last video I started this chapter. I discussed about the density and the units of density and how to determine the density of a solid of an of a solid of a regular solid rather of a regular solid, and then I discussed about the vessels for measuring the volume, and now I have come to discuss the determination of a solid by using a measuring cylinder. Okay, for this we need to have a measuring cylinder. Okay, and for that before measuring this solid, for measuring the density of a solid, we first need to know the mass and the volume of the solid. For the mass, say it's m grams, which can be determined by a physical balance. Okay, if I weigh the mass, if we weigh the mass of the solid by a physical balance or a beam balance, you can say very accurately, we can get the weight of the mass of the solid. Then for the volume, what do? We take a measuring cylinder in which we pour some water in it. Okay, now we note down the height, the initial level of the water in the cylinder. It's graduated. This measuring cylinder is graduated. Okay, and now what happens? We tie with a string and drop the solid cylinder gently so that no water spills out. Okay, and now gently drop down this solid inside that measuring cylinder. Okay, inside the water, and we see the level of water has come to some certain height. It has increased its height. Okay, because the water, the solid which has been dropped in, that has displaced its own volume. So that much water has come up. So we now what we will do, the take the final reading, final level of the water. Now, for example, if we take the initial level as 50 centimeter cube and the final level as 75 centimeter cube, so volume of the solid will be the volume of the water displaced. So that much, that is final level minus initial level, that is 75 minus 50 in this case, that is equal to 25 centimeter cube. Now we know the density, the mass of the solid is m grams and the volume is 25 centimeter cube, or you can say it's v centimeter cube. Okay, so the density will be m by v. Okay, so that will be the the density of the solid by using a measuring cylinder. Okay, next we come to measuring a measurement of density of irregular solid using an Eureka can. Okay, a Eureka can. What is a Eureka can? It's a iron vessel which has a spout. Okay, see, you can see from the picture, there's a spout which is coming out from the iron vessel, the vessel which has been kept on the wooden box. Okay, that is the Eureka can. Okay, and now when it is filled with water, uh, it is filled to a certain height. That height should be almost equal to that of the spout. Okay, that means where the spout is opening from the can, till that height the water should be filled. Okay, now the solid which has to be measured, the volume which the solid whose volume has to be measured, that solid is gently dipped into that uh, cylinder, into that can. Okay, what happens, as it is to the brink, this one, the water is as it is to the brink of the spout. So what happens, as soon as you drop the solid, dip the solid inside that water, inside the water of the can, the water will rise because the solid will displace its own volume. So the water will rise. Now when it will rise, it will come out from the spout. Okay, it will come out from the spout, and that will come out and collect on the measuring cylinder which has been kept just underneath the spout. Okay, the water which is coming out of the spout, that the amount of water, the volume of water that is coming out of the spout, that will be the volume of the irregular solid. Okay, so the solid displaces water which will flow out from the spout with the measuring cylinder into the measuring cylinder, and now we should record the volume of the water which is overflown into the measuring cylinder. This gives the volume of the solid. Now mass of the solid is determined by physical balance, or we can say a beam balance very accurately. That is, say, m grams, and volume of the solid, that is the volume of the water which has been come out from the spout in the measuring cylinder, that is said it is V centimeter cube. So density will be m by V grams per centimeter cube. Next is measurement of a density of a liquid by using a density bottle. Till now we were discussing about the density of a solid. Now we are started discussing the density of a liquid. Now this is done by a density bottle. See, the first picture is of a density bottle. Okay, it's a small glass bottle having a close fitting ground glass stopper. It has a glass stopper at its neck with a small capillary tube. Okay, there's a small capillary tube inside the glass stopper. What happens when you fill the bottle, density bottle, say it is generally of a capacity of 50 ml. Okay, generally it is used 50 ml bottle is used. So say we fill the water till the brink of the bottle. Now as soon as we put the glass topper inside, the liquid will, the excess of the liquid will come out of the capillary tube. So when the bottle is completely filled with some liquid and the stopper is inserted, then excess liquid rises up through this capillary tube and drains out. This in turn ensures that the bottle contains equal volume of liquid when filled with different liquids. Okay, so it will ensure that the bottle contains equal volumes of liquid. Nothing more or nothing less. That will be equal volumes of different liquids. Okay. Now, how do we measure the density of a liquid by this density bottle? First, we need to wash the bottle, clean it, dry it with distilled water. We have to clean it, then we dry it, and then dry it in hot air. Then we put the stopper inside, and then we take its mass by a physical balance. Then the bottle is filled with the liquid, again with distilled water, and the stopper is inserted, and again we we wipe out the outside the bottle so that no water is sticking out of the outside the bottle, okay, outside the bottle, and then we take its mass by a physical balance. Then the water is poured off, again it is dried with hot air, and again it is filled with the given liquid. Okay, same process, insert the stopper, and then we take the mass by using a physical balance. Okay, so what happens now, we take the mass of the empty bottle, say m1 grams, empty bottle plus water, that is after putting water inside the bottle, we take it, it is, say it is m2 grams. Now water, we drain it out, the water which we poured inside the bottle, now we drain it out, dry it, and then pour liquid. Now this time the empty bottle and liquid, empty bottle plus the liquid, we weigh it as m3 grams. So mass of only water will be m2 minus m1, that is m2 is empty bottle plus water minus the empty bottle. So water's weight, water mass will be getting as m2 minus m1, and again mass of only liquid will be m3 minus m1. Now 1 gram of water, we know it's 1 centimeter cube. Okay, so volume of water will be m2 minus m1 centimeter cube, and volume of the bottle will be m3, volume of the water will be m2 minus m1 centimeter cube. So therefore we can say that volume of the liquid will be equal to volume of water, that is m2 minus m1 centimeter cube. Now the density of the liquid, we know mass of the liquid by volume of the liquid. Now we have come we know that the mass of the liquid is m3 minus m1 grams and volume of the liquid is m2 minus m1 centimeter cube. For example, if the mass of the liquid is 42 grams and volume of the liquid is 50 centimeter cube, therefore the density of the liquid will be 42 by 50 centimeter cube, that will be equal to 0.84 grams per centimeter cube. Okay. Now for the variation of the density of the liquids and gases with temperature. What happens? Solids, liquids and gases, they all expand on heating and they all contract on cooling, that we know. Okay, but you know that they have molecules and the kinetic energy due to the molecules which gain the kinetic energy due to heating, that helps them to expand on heating and contract on cooling. So, but in this case, the solids, the expansion with the rise in temperature is almost negligible. Density of a solid, that is m by v, hardly changes with the increase in temperature. Okay, or there is a minimum change in temperature. When for a minimum change in temperature, that is from 20 degrees to 40 degrees centigrade, the density of a solid does not change. There is a very negligible change. Okay, and in case of liquids and gases, there is a large change in volume with the rise in temperature. When the mass of a gas or a liquid remain constant, and if the volume is increased, the rise in temperature, then there will decrease. Okay. The density will decrease. Okay, that density will decrease. Okay, so what happens if when the mass of a gas or a liquid remains constant and if their volume is increased with the rise in temperature, then their density will decrease. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this and my previous video regarding this chapter. If you have any doubt, please to write in the comment box. And I hope you are liking the videos. So if you are liking it, please press the like button and share with your friends so that they can also be benefited from these videos. And you can also give suggestions if you want any improvement in these videos. Okay. And if you are a new viewer to my channel, not subscribed yet, please to subscribe to get the notification of my next video. Thank you.